Welcome to The Explainer. Today, we're looking at a literal textbook David versus Goliath story. So on one side, you have this incredibly expensive, totally closed-off legacy hardware industry. And on the other, a site reliability engineer armed with open-source hardware, some basic networking shops, and, honestly, a serious drive to disrupt an incredibly frustrating system. We're going to see how this one developer managed to replace a six-figure bowling alley control system using literally just a fistful of cheap microcontrollers. It's an absolute masterclass in how modern commodity tech can completely dismantle vendor lock-in. Okay, let's dive into this. We're going to bridge a really relatable business problem with a hardcore technical deep dive today. We'll start with the six-figure bowling problem, check out the open-source hardware solution, unpack the ESP32 and ESPNow mesh, dive into the Redis pub/sub architecture, and then wrap up with how this breaks vendor lock-in. All right, part one, the six-figure bowling problem. So the context here is actually pretty incredible. A family bought this abandoned 8-lane bowling center out in the rural Midwest, right? They paid just $105,000 for it, hoping to provide some recreation for their small town. But to replace the broken, closed-off scoring system that was installed back in 2008, they were quoted an absolutely staggering $120,000. I mean, that is more than they paid for the entire building. And it gets worse. If they just wanted to fix the existing system, replacement parts for this proprietary hardware ran an absurd $4,000 per lane pair. Literally every new feature, every customization was an extra line item. And this brilliantly illustrates just how absurd the whole situation really is. The heavy lifting machines, the pin setters and the ball returns, they are literally 70-year-old mechanical beasts. As the proprietor pointed out on Hacker News, what is this quote-unquote advanced 2008 computer actually doing back there? It's literally just actuating a single relay to trigger a mechanical machine. The rest of the setup is strictly mechanical. Just imagine holding a six-figure invoice for a computer that essentially just flips a switch. Naturally, this developer got pretty upset, and then they got to work. Which brings us to part two, the open-source hardware solution. Our SRE knew for a fact they could bypass these legacy vendors. Look at this direct comparison. You've got the legacy system on one hand, up to $120,000, completely closed APIs, a $4,000 toll just for replacement parts and total vendor lock-in. Now look at the prototype they built, which they're calling Open Lane Link. The cost? Just $200 per lane pair. Actually, even if you want to get fancy with it, it's maybe $400. For an entire 8-lane alley, the whole shebang costs about $1,600. It's fully open source, built entirely on cheap commodity parts, and because you own the hardware, your repair times drop from waiting days for a specialized technician to, under 10 minutes. So how on earth is it so cheap? Well, it relies on completely basic, ubiquitous components. We're talking standard microcontrollers, regular relays, optocouplers, and simple IR brake beam sensors to detect the bowling ball. Because these parts are practically dirt cheap, you don't even bother diagnosing a broken board when something goes wrong. You just keep a fistful of pre-flashed ESP32 controllers in a desk drawer. If a lane suddenly goes down, you just unplug the dead controller, plug in a $5 spare, and boom, the lane is back online. All right, part three, let's talk about the ESP32 and ESPNow mesh. Let's move to and see how this builds across 4 distinct architectural layers, because having cheap hardware is really only half the battle, right? It has to communicate reliably. First up, you have the edge layer. These are the sensors and relays sitting right there on the actual lanes. Then the mesh layer, which is how these edge devices talk to each other wirelessly. Third is the gateway layer, catching those wireless signals and translating them. And finally, the application layer, where that data is actually used for scoring and the user interface. Now, the absolute secret sauce in that mesh layer is something called ESPNow. According to the official Espressive docs, ESPNow is a low-power wireless protocol that uses Wi-Fi packets, but crucially, it does this for connectionless messaging. This is a big deal because it means the microcontrollers aren't wasting precious time trying to establish heavy, standard Wi-Fi handshakes with a router. They're just instantly blasting out sensor events like, hey, a pin fell over, and instantly accepting relay commands. It's incredibly fast and honestly perfect for this kind of real-time trigger environment. The network itself is arranged in a star topology, but we need a massive engineering reality check here. Bowling alleys are basically giant metal boxes filled with massive 70-year-old, heavily vibrating electrical motors. The RF environment in there is insanely noisy. So the architecture includes a mandatory RS-485 wired serial bus as a fallback. If the wireless mesh degrades because some massive motor spins up and causes a bunch of interference, the system instantly falls back to the hardwired connection, making sure the game never skips a beat. Moving right along to part 4, the Redis pub-sub architecture. So how exactly does a physical pin falling over translate into a score on a TV screen? All those signals from the Edge Mesh report back to a single gateway ESP32. This gateway is physically connected via a UART serial port to a standard Raspberry Pi. And that Raspberry Pi acts as the main lane computer. This is the exact bridge where the physical world crosses over into the software world. Now, what's really interesting about this slide is how they handle that incoming data. The Raspberry Pi runs Redis. If you check the Redis docs, pub/sub, which just stands for publish and subscribe, is a messaging paradigm that decouples publishers from subscribers by categorizing messages into specific channels. So when the gateway gets a packet saying a pin dropped, it translates that into a Redis event and just publishes it to a channel. The beauty of this is that the physical hardware doesn't need to know a single thing about the UI, it just publishes the event and goes about its day. From there, a state machine running on the Pi keeps track of the actual game rules, fouls, and pin states. And because all this data is just sitting right there in Redis, literally any standard web developer can step in. Using WebSockets to stream those Redis events, they built a fully custom React UI for the overhead screens. You don't need clunky proprietary bowling software anymore. Any reactive can now code up custom bowling animations, retro 80s themes, or completely new scoring logic using standard modern web tools. It's a massive, massive paradigm shift. Which leads us to our final section, part 5, breaking vendor lock-in. What this developer achieved goes way, way beyond just a single bowling alley. There are some hard lessons here for basically any engineer. Look, while the hardware is dirt cheap, writing deterministic packet handling takes some very serious engineering effort. Physical fallbacks like that RS-45 wiring are absolutely mandatory in industrial settings. But the payoffs, they are huge. Pre-flashing commodity spares cuts your downtime to minutes. Using a Pi and React allows for lightning-fast iteration. And most importantly, owning your data completely changes your service level agreement. You aren't waiting on a vendor's support desk on a Friday night anymore. You control your own uptime. This quote from the creator perfectly sums up the ultimate victory of the OpenLink project. By totally rejecting the black box appliance, they gained absolute freedom. They don't have to pay a vendor hundreds of dollars just to change the font colors on their screens. They aren't paying a premium to white label their own equipment. They own the hardware. They own the entire software stack, and they own every single byte of data it generates. So the crucial point is this. If a $120,000 closed bowling system can be functionally replaced by just $1,600 of open source components and some clever software architecture, where else is this happening right now? Look around at other legacy industries, manufacturing, agriculture, local recreation. How many of them are gated by massively overpriced computers that at the end of the day just flip mechanical relays? The tools to disrupt them are literally sitting right there in our desk drawers, just waiting to be built.